Hey everyone, so in this video we'll move ahead of our implementation of this project. So this image has changed because I have rerun the your notebook. So in this video we are going to start with first of all we will be defining the basic hyperparameters. So we're going to say hyperparameters, and after that we are also going to do the transforms and augmentation, the transforms that we are going to see, and after that we'll do dataset and data loader. But I hope this is going to be a small video because all of them are very basic. Okay, so what are the hyperparameters that we need? We first need the batch size. So the batch size is basically the number of images at once that will be given to the model. In my case, I'm going to keep it 64. You can also keep it 64, or you can try with 32 or 128. After that, we have the learning rate. So this is for your optimizers. So we'll be using the Adam optimizer, and the learning rate I'm keeping at 0.001. Okay, then we will use number of epochs, the number of times we want our training and validation loop to run. Right now I'm setting it to 1, but we will be using 5 when we train the model. Okay, so okay, let's just keep 5. Maybe I'll change later. Okay, so our hyperparameters are defined. If you want to have some more hyperparameters, you can definitely have that, but again it depends of what are the things that you're using. Okay, so let's say if you're using dropout, you might add dropout, but in this case we are not using it. After that, what we need to do is we need to define the transforms that will happen on our images. So all of these things are already covered in the PyTorch series, so but we should definitely try to understand. So I'm going to have a variable. I'm going to name it transform. Okay, and I am going to say transforms dot compose. Now just wait a second in order to see why did I write transform. This is the S is missing over here. Okay, so this is transform, and this is the variable, and transforms is something that you have already imported over here. So this is a standard library in Torch Vision. Okay, so Torch Vision is a library. This is a standard stuff. After that, what we need to do, we'll be doing 3 things. So I'm going to say transforms dot. So these are compose is a way by which you club more than one transforms. Okay, so what is the first transform? It is tensor dot transform. What this is going to do, this is going to basically normalize the image from, so let's say the images generally are, I mean not generally, all the images are from 0 to 255 range. It will normalize it to 0 to 1 range. That is what it is going to do. Okay, after that what you can do is, or I think it's -1 to 1, but just check it. Okay, it's you can also go and check it. Maybe I'll do it later, but basically what it does is it reduces the size from 0 to 255 to 0 to 1, I believe. Okay, after that what you're going to do, you have to resize the image, and I will tell you why. The reason you have to resize the images, I initially thought all the images in this data set are of 224 cross 224, 224 cross 224. However, some of the images were actually not. Even in the data set it was given that all images are 224 224. I got an error, so what I did, I used the resize function in PyTorch, in Torch Vision, and I was able to remove that particular error. So you can also go and see. If you don't want to see, it's fine. So you just have to resize all the images to 224 cross 224, and then you also need to pass anti-alias. This was again throwing error, so basically I had to use this. So is anti-alias equal to in our case we will put it to true. Okay, after that what we are going to do is the simple one. We are going to normalize our the images, and so we have already converted the images to tensor, which means it is already in the range 0 to 1 or -1 to 1, whatever it is. You also need to make sure that you are centralizing. So what happens is even if let's say your images are like this. Okay, so distribution of, so this is x-axis, this is y-axis, so distribution of your images is something like let's say like this. Okay, what you ideally want is not this, but something like a normal distribution along the mean. Okay, so basically let's say this is very fat, so you want something like a normal distribution, which means you need to change the mean. So this over here is the mean. So let's say if this is the center, not the old one, the new one is the center, so this is the mean. So let's say mean, so you want mean or mu to be equal to 0, and you want the standard deviation to be equal to 1. That's all you want. Okay, so what you would need to do over here is we would need to say normalize. Okay, and I'm not going to give the value. I have already written it somewhere, but now it seems like it's gone, or yeah, the way it is you can get the value is, you need to go, this link will be there in the description. So you need to go to the website of PyTorch Resnet 18, and you need to go over here, and then you see, so obviously values are first rescaled to then and normalized using this. So you need to take the mean over here, as you can see, this, copy it over here and then paste it over here. That is all you need to do. Okay, you took the values from here, so I think std will become like this. Okay, so once this is done, you have to put the comma, mean equal to this and standard deviation equal to this, and you have to hit shift and enter. So these are your transforms that you have already taken. Okay, so let's go ahead and now go for your data set, and this is the main portion of this video, because and one of the very important portions of this particular project that we need to make sure that we have is dataset. Now one good thing that this dataset provides is that, and that is the reason why I have chosen this dataset, is that, remember, there is a train folder, right? And inside the train there is species 1. Okay, and inside this is a folder, this is again a folder, train folder. Inside these data images, you say I1 image 1, I2 image, so let's say this species of some bird. Okay, so all these images are of the same bird, of, so like I of 150. And then again you have folder 2, species 2 is another folder, then again species 3 is another folder, and so on and so forth. What this is doing is, we don't have to write here something called as a custom dataset, dataset class that we do generally in PyTorch. We say no class, I generally use custat, and then you write over here torch dot utils dot data dot dataset, small d, dataset, and then you over here you go and say define init, and then you pass certain functions, and then you say super, or in this case you don't say super. Okay, whatever, the idea is the same thing. Okay, we need to make sure that we, in this case, we won't be using this custom implementation, because our data set is so nicely managed in terms of folders. We can use something called as image folder. I will show you over here, image folder in PyTorch. Okay, so I hope it comes here, it comes in the first place itself. So you can see generally this is the, so you can see over here dogs are, all the images of dogs are in the, you can see over here, dog folder. Okay, and all the images of cats are in the cat folder. It means basically that we don't have to care about writing the custom functions. Okay, so the way I'm going to define my data set is, I'm going to say train data set, and I'm going to say torch vision dot data sets, and after that I'm going to say image and folder. So image folder, yes, and you need to pass in certain your parameters. So I have to say root is train underscore path. After that I'm going to say transform. So the transform that we have already defined over here is I'm just going to write again transform. Okay, so the transformations are also given over here. Now this is for the train data set. You also want for the validation data set. So what you can do over here is, you can copy and paste over here. Instead of train you can write val, and instead of train path you can write val path. Okay, and rest everything remains the same thing for the test. So you can go over here and you say test underscore data, and instead of train path you can say test path. Okay, and transform remains the same. Now hit shift and enter. So once this particular thing is done, it takes some time. So basically what it does is, it as I said, it takes some time, but this is the beauty of image folder. You don't have to come and write this particular custom data set. The reason why this is cumbersome is, you will have to define a way by which for every index your image and class will be used, will be returned for every index by. So at the end you will for example, the structure is, let's say, class cust dat. Okay, and whatever I said, you need to define init function, def init, so 2 dashes. Okay, and then you have to define another one which is length, and you have to also so here it will be some return over here, and then you also need to define over here get item, and in here you will have to pass an index, and given every index you need to make sure that you are able to return, for every index you are able to return an image and what to say your real label. You want to return the label. This entire thing we will not have to do because we are using image folder. Okay, so the data set is run. Now what we need to do is we need to have our data loaders. Okay, so what is data loader? See, this is a class. Okay, this is an object basically. So what you need is you need a data loader in order to use this particular object and create your a data set, which I will show you how to do it. Okay, so I'm going to say train loader. Okay, so let me just have data loader. Okay, let's go. Let's get some room over here. Yeah, so I'm going to say train underscore loader, and then I'm going to say torch dot utils dot data loader, capital L, huh? So data loader is there. Now what you need to do after that is you basically have to define certain parameters, and the first parameter is the object that is you have passed over here. Okay, the class over here, basically not the object, the class. So this is the class. The train dataset is the class for the dataset. Okay, after that what you need to do is you need to mention whether you are going to use shuffle or not. Shuffle is basically randomizing the, so whenever you are saying shuffle equal to false, so what will happen is index will be passed from 1 2 3 4 up to, so let's say there are 80,000 something 500 614, I don't remember the exact number images. Index will be passed like this 1 2 3 in ascending order. If you say shuffle equal to true, so this is shuffle equal to false. Okay, so here no shuffling, but if you say shuffle equal to true, this entire thing will be random. So first you can have 5,361, and then you can have 78,124, then you can have 3, then you can have 981, and so on and so on. So the entire range will be randomized over here. And why this is useful? Generally what happens is, this helps in better training. Why? Because in every batch what will happen is no single class will dominate. Okay, so it is like assuming that all classes are somewhat equally represented. This will help in stable training. That is the entire goal. What is stable training? It will be easier to reach the convergence, basically convergence for the optimization function. Okay, so let's get back. So shuffle equal to true. Now you have understood that. After that what you want is you want something called as batch size, and remember we have already defined it as a hyperparameter over here. You can see over here batch size is defined as 64. So you have already sorted that out. And what you need to do, you also need to define it for validation and test. Okay, so instead of train loader I'm going to say val loader, and train dataset I'm going to say val dataset. Here you can keep for false, and the reason is since we are not training in this, because when validation we will be using with torch.nograd, which means no training will happen. You don't need to care about the optimizer, and since you don't need to care about the optimizer, shuffle equal to true doesn't make sense, right? So you can keep like this. One important thing over here is you have to use something called as drop last equal to true. Ideally this shouldn't have given a problem, but when I was testing it, to me it gave a problem. So what you can do is instead of using this, first remove this. Okay, you remove this over here and now use your val data loader. If there is some problem, you just add this back. Okay, same. I hope you were able to understand. Now what you need to do is now instead of val, now you also need the test loader. Okay, same story. You go over here, instead of train you have test, instead of train dataset you have test dataset, and you keep everything as a, so shuffle equal to false, and everything else remains the same, and you hit shift and enter. So this will create the data loader. Okay, so I hope till here we are fine. So what we did 4 things basically. We defined hyperparameters, we also defined transforms, and what we also did is so here, you know, in transforms, what you could have also done is you could have done something called as image data augmentations. So basically you could have said transforms dot, let's say, random horizontal flip. Okay, and then you could have passed 0.5, or I think even that is not necessary, and you could have used this. Now why I'm not using it is because this type of things is these data augmentation, what they do is they make your training very slow. Why? Because all these augmentations are done during the fly. So during training this is done, which means it, and this for example, this resizing operation that I'm doing, it's already taking time. Okay, if you add some more, it will take more time, which means our training is going to be slower and we will have to spend more time, and that is not what we want to do. So what is the solution? The solution is this: you pre-compute. So it's more of a trade-off, because you know, it will require more space, because you will have to save the to say newer images that you will get from here, pre-compute the augmentations, and then what you do, you basically save them. Okay, so you save those augmentations. What will happen? Time consumption will get more, but sorry, space consumption will be more. Why? Because you're not generating on the fly, you are saving those images, but time will be reduced, and this is much more important than space, is something that I want to tell you. So you could add this, you can also add, let's say, transforms dot center crop is also there. So there are many things. Okay, but after center crop, you should remember that resize is there, otherwise you will have problems. It is very, very important that all your images are of the same shape and size. Otherwise what will happen, you will have to use something called as custom collate functions. That are custom collate, that is some video that I have already uploaded on PyTorch on my channel, and I'll tell you, you don't want to do this, because it's not, I would not say it's hard, it's just tension and time consuming. That's the point of this. Okay, so yeah, I think in the next video we are going to finally create our model, and we'll not be training it, we'll be training it in the next to next video, but we will be creating our model in the next videos. So I hope you like the video. If you like the video, please like and subscribe. Thank you very much, and bye.